Tonight we begin a journey not through space, but through something far more elusive, time itself. You've heard that time is constant, that a second is a second, no matter where you are. But tonight I'll gently challenge that idea, because time isn't what you think it is. Above you, satellites tick just a little faster than the clock beside your bed. In deep orbit, astronauts age slower by fractions of a second that quietly accumulate. Near black holes, time can nearly stop. Even your feet and your head are living at slightly different speeds. This isn't science fiction. It's Einstein's world, where light never bends, so time must. In this sleep story, we'll explore why time moves slower in space, and what that means not just for scientists and astronauts, but for you, for your body, your memories, your breath. We've covered this journey in 10 immersive chapters, from how your own heartbeat keeps time, to why clocks disagree at the top of a mountain, to what happens when twins live apart, one in orbit, one on Earth. You'll hear about the stretching of seconds, the silence of orbital sleep, and the strange feeling of reuniting after time has bent. But don't worry, we won't rush. Time is not in charge here, you are. Before we begin, tell me this in the comments. What time is it for you right now? And where in the world are you listening from? Because while it may be 11:47 p.m. for you, someone else is hearing these same words at sunrise. And physics says your two nows are not quite the same. We are all moving through time differently. So now please, dim the lights, close your eyes, and let yourself drift. You're about to fall asleep to the rhythm of the universe. This is the Sleepy Scholar, and this is your whispered tour through the strange poetic science of time. Your heart has always known time, long before you learned what a second meant. It doesn't need to be told when to beat. It simply does. Again and again, a quiet pulse beneath your ribs, keeping rhythm even in the deepest silence. You lie still now, listening to the hush of night, and yet within you there is motion, a tiny contraction, a pause, another contraction. This too is a kind of clock. A clock made of flesh and instinct, not numbers and gears. There's something profoundly soothing about knowing your body has never forgotten the rhythm. Even as you sleep, your blood flows in gentle waves, your lungs expand and release in unspoken tempo. The cells in your muscles, your brain, even your fingertips, all of them live by an internal cadence, a biochemical ballet that marks the passage of time far more intimately than a ticking watch. You were born into rhythm. In the womb, your mother's heartbeat was the first metronome your ears ever heard. The thump, 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 steady and safe, shaped your understanding of what it means for something to begin, to continue, and to pause. Later you learned to walk, and every step followed the beat your body already knew. Time wasn't something outside of you. It was you. Even now, when you aren't thinking about it, your body remains an orchestra of clocks. In your brain, neurons fire in pulses that regulate sleep and alertness. In your gut, microbial colonies live on circadian schedules, waking and resting in concert with light and darkness. Your temperature rises and falls predictably each day, like the sun rising and setting within your skin, and none of this requires your conscious attention. This is what scientists call biological time, and it's astonishingly precise. Your body anticipates dawn before it happens. Your blood pressure dips before bedtime. Your mind begins to dim before the world dims. Even if you were kept in darkness for days, no sun, no clock, no cues, your body would still count time with eerie accuracy, as if it could feel the slow spin of the planet without looking. And yet it's fragile too. Jet lag, for instance, is not just a nuisance, it's your inner clock falling out of sync with the world. You cross a continent in hours, but your cells need days to catch up. The light tells you it's morning, but your stomach insists it's midnight. This friction between body and world, between internal and external time, can make everything feel slightly off, as if you're out of phase with reality itself. You've probably felt it before, those nights when your body refuses to sleep, even though the clock insists it's late. Or mornings when you wake too early, your breath shallow, your limbs heavy, your body knows something is misaligned. Time is no longer a shared agreement between your cells and the stars. It becomes something to wrestle with. And yet, even then, even when the world feels skewed, the clock in your chest remains faithful. It doesn't give up. It keeps counting in quiet, invisible numbers. Calcium ions trickling into heart cells, electrical impulses spreading across a muscle wall, a surge of blood pushing against arteries, whispering now, now. We rarely think of time this way, as a companion rather than a ruler. We treat clocks as external judges, rigid, cold, objective. But your body never learned time from a clock. It learned it from movement, from rhythm, from breath. The earliest humans didn't need numbers to feel the passing of a season. They felt it in their bones, in the warmth returning to soil, in the softness of rain, in the lengthening of light. Even today, beneath all our machines and schedules, you still live this way. You feel that subtle shift in mood as dusk approaches. Your hunger arrives not at noon, because the clock strikes 12, but because your body remembers the sun's angle. You begin to yawn not because bedtime has come, but because your melatonin has begun to rise in response to darkening skies. In this way, time is not merely measured. It is felt, it is absorbed through skin and eye, breath and bone, and this internal awareness is not something small or primitive. It is astonishing. In fact, it may be the very foundation upon which all other understandings of time rest. When physicists began to study the nature of time itself, to question whether time flows the same for everyone, everywhere, they had to let go of the idea that time was uniform. The ticking of a clock on Earth is not the same as the ticking of a clock in orbit. A second experienced on a spaceship moving near the speed of light is not the same as a second in your living room. But even before those grand revelations, the body already knew time is not a constant. It is a relationship. Your heart speeds up when you are afraid. It slows when you are calm. It races when you climb stairs, and drifts when you float in warm water. Time becomes elastic, not because the universe bends, but because your body does. You experience time not as a stream, but as a sea, with tides that rise and fall depending on emotion, movement, memory. Think of those moments when time seemed to vanish. A perfect sunset, a quiet morning, a first kiss. There were no clocks in those moments, only you and the unfolding present. Your body was the only instrument marking the passage, your breath deepening, your chest softening, your awareness expanding. Now imagine taking that body, this sensitive, intuitive body, and placing it in space, far above Earth, away from sunsets, from gravity, from the familiar spin of day into night. What would time feel like then? What would the rhythm become? Would your heart still beat in its gentle cadence, or would it drift unanchored in the silence? We'll explore that soon. But for now, as you lie here, let your attention return to the rhythm you've always known. Place your hand over your heart if you like. Feel it there, quiet and patient, marking time in the only way that ever truly mattered. And as your breath slows, as your body softens, you begin to wonder, not with urgency, but with curiosity, how something so simple as a heartbeat could be part of something so vast. Time does not begin with clocks. It begins with you, and tomorrow we'll see how far that rhythm can stretch. You breathe, and in that breath something ancient unfolds, a rise in your chest, a soft letting go. You may not think of it this way, but every breath you take is a timekeeper. Inhale, a new beginning. Exhale, a quiet release. The rhythm has been with you since birth, shaping your sense of now, your awareness of passage, your connection to the present. Breathing is time made visible, made audible, made physical, a moment you can feel. Think of how many moments have passed like this. You blink, and the world shifts slightly, a flicker of lashes and suddenly the light changes. Even the blink is a measure of time. On average, you blink every 4 to 6 seconds, a gentle reset, a miniature pause. In the time it takes you to finish a thought, you may have blinked once or twice, without even knowing. That's how subtle the body's clocks are, not just in what they count, but in how quietly they do so. We often believe that time is what happens on the outside, what clocks and calendars tell us, but your body disagrees. It doesn't follow the rigid ticks of seconds marching forward. It listens instead to pulses, to breaths, to glances of light. Even your skin has its own rhythm, absorbing the day in waves of temperature and shadow. These internal cues shape how you move through the hours. They tell you when to wake, when to eat, when to rest. Even if no one told you what time it was, your body would still know. This internal knowing is called circadian rhythm, from the Latin circa diem, meaning about a day. It is your body's way of aligning itself with the 24-hour cycle of light and dark, even in the absence of clocks. Deep within your brain, a cluster of nerve cells called the suprachiasmatic nucleus sits just above the point where your optic nerves cross. It is your biological timekeeper, watching for light, listening for dark, adjusting your entire system accordingly. When morning light touches your eyes, the signal travels to this tiny cluster, triggering a cascade. Cortisol rises, heart rate quickens, body temperature warms. You don't have to think about any of it. Your body simply prepares. Later, as evening falls and light dims, melatonin rises, muscles begin to slow, and your breath deepens. These shifts are not choices, they are ancient responses, written into you by millennia of sunlight and sleep. But it's not only light that speaks to this inner clock. Food, movement, even conversation can nudge it. If you eat breakfast too late, or stay awake too long under artificial light, your rhythm begins to sway, not break, but waver, like a metronome tapped off balance. That's why you feel groggy on certain mornings, or restless during some nights. Your body is trying to listen to the rhythm, but the signals have become noisy. The modern world has made this worse. We light our homes at midnight, scroll through glowing screens in bed, sip coffee in the darkness of early dawn. We fly across time zones, skip meals, push ourselves past exhaustion, and still our bodies try to hold rhythm, like a violinist playing through thunder. It's no wonder we sometimes feel out of tune. But even in this dissonance, the body does not give up. It adapts, gently, patiently. It recalibrates. It learns from light and motion, and when given a chance, a week in nature, a break from screens, a few quiet days of rest, it returns to its rhythm, almost gratefully. You begin to wake with the sun again. You fall asleep when the sky darkens. Your appetite sinks with the day. Your breath feels like it belongs again. And here's what's remarkable. This rhythm isn't just emotional or spiritual, it's measurable. Scientists have studied people in caves, cut off from all external cues, no clocks, no windows, no contact, and still, their bodies followed a near 24-hour cycle. Their sleep, temperature, hormone levels, all moved in predictable waves. Time, it seems, lives in us. Even animals, from bees to birds, possess these rhythms. Migrations follow seasonal clocks. Flowers bloom at set hours. Coral reefs release their spawn in mass synchrony, not by human calendars, but by moonlight, tide, and internal sense. The universe whispers time, and every living thing listens. And when it comes to perception, things get even more delicate. You've felt it, how time can stretch or shrink depending on mood. A joyful hour feels like a minute. A stressful second can feel eternal. This isn't just poetic language. Neuroscience supports it. Your brain actually processes time differently, under varying conditions. In fear, the amygdala becomes more active, encoding more memories in a short span, making moments seem longer in hindsight. In flow, that blissful state of absorption, you process time more efficiently, letting it slip past like water. Even attention plays a role. When you're focused on time, it slows. Think of waiting in line, watching seconds crawl. But when you're immersed in music, art or conversation, hours vanish. This is not an illusion. It's how the brain allocates awareness. Time isn't only what passes, it's what you notice. And still, at the root of all this noticing, is the breath. Each inhale a moment born, each exhale a moment released. When you slow your breathing, time seems to slow with it. This is why meditation feels timeless, why watching a candle flicker or rain fall can make an hour dissolve. You return to rhythm, and rhythm returns you to presence. In space, this relationship becomes even more fascinating. Without Earth's day-night cycle, astronauts rely entirely on artificial cues to maintain rhythm. Lights are programmed to simulate sunrises and sunsets. Meals are timed with precision. Sleep schedules are rigidly enforced. Without this structure, the circadian system falters, leading to fatigue, confusion, even depression. It shows us just how deeply time and biology are intertwined. But more than that, it shows us that time is not simply measured, it is experienced, and experience depends on the body. Your body, this vessel of breath and blood that carries you through each hour, quietly marking its own kind of calendar. You may be lying still now, eyes growing heavy, thoughts beginning to fade, but inside you, the rhythm continues. Your lungs rise and fall, your heart moves in softened beats, your mind drifts, not away from time, but deeper into it, into the felt sense of seconds unfolding. And perhaps that's the secret. Time isn't something to chase or hold, it is something to inhabit. And in this breath, in this moment, you are doing exactly that. There's a quiet intelligence inside you, older than words. It doesn't ask for attention, it doesn't demand applause, but it knows. Long before you could read a clock or understand the sweep of a minute hand, your body was already listening to time. Not the mechanical kind, but the soft pulse of internal rhythms, of cycles that repeat, of patterns etched into your flesh and your breath. Even now, as you lie still in the dark, that intelligence continues, shaping every moment you feel without needing to name it. Your cells don't speak the language of hours or minutes. They speak in pulses, in the rise and fall of chemical signals, in the gentle tide of hormones, in the release of energy at just the right moment. Your brain, your heart, your skin, each has its own way of knowing when it is time to rise, time to sleep, time to heal. These are your body's clocks, and they are remarkably precise. Think about it, you begin to feel sleepy, not just because the sun has gone down, but because your pineal gland, deep in your brain, has begun to release melatonin, not on a whim, but in response to fading light. It happens even if you don't look out the window. Your eyes sense the shift and pass the message inward, and if you stay up too long under artificial light, your body becomes confused, unsure of whether to rest or remain alert. You feel it as fog, as restlessness, as a tension just beneath the surface of your form. Even digestion obeys time. Your stomach expects food at certain intervals. It prepares acids and enzymes in anticipation, not as a reaction. When you eat too late or skip a meal, you feel it not just in hunger, but in your energy, your clarity, your comfort. This is not about habits. It's about rhythms encoded into every system. Your body is not guessing, it's remembering. This remembering is not like recalling a date or a fact. It is deeper, cellular, metabolic, almost instinctive. It's why shift workers often struggle with health, why long-haul travelers feel disoriented. You can change your environment in an instant, but your body takes time to follow. It has to relearn the cues, it has to find its rhythm again. And this rhythm isn't just about cycles, it's about calibration.
Every internal process must coordinate with others. Your sleep depends on temperature, which depends on blood flow, which depends on your heart rate, which depends on your oxygen intake. Everything is linked. Everything is time. And though it all happens without your awareness, it creates the experience you call now. You might not notice the fine-tuning, but your body is always adjusting. A sudden noise causes a spike in alertness. A warm bath signals relaxation. A long sigh resets your nervous system. Even emotions play a role. When you're anxious, your perception of time changes. Minutes feel longer. Your thoughts race. Your heartbeat quickens. When you're calm, the opposite happens. Time softens, stretches, becomes less demanding. This is what scientists mean when they say time is subjective. It doesn't mean time isn't real. It means your experience of it depends on the body through which you live. And your body, despite all it endures, is always trying to keep you in balance. It's always searching for the tempo that feels right, not just for survival, but for presence. Consider your heartbeat again, not just the rhythm, but the variability, how it subtly shifts from one beat. This variability is not a flaw, it's a sign of adaptability, of resilience. A healthy heart doesn't beat like a drum machine, it beats like a symphony, steady, but alive, responsive, aware. It quickens when you stand, it slows when you exhale, it follows your mood, your thoughts, even your dreams. Your nervous system listens closely to this rhythm. The parasympathetic branch, responsible for rest and restoration, sends signals to slow things down when you are safe. It encourages digestion, deep breathing, emotional openness. The sympathetic branch, tuned to alertness and survival, prepares you for action, for danger, for focus. Together, they keep you balanced, and their dance is choreographed by time. Even your memories are shaped by this choreography. Your brain encodes events based on emotional salience and temporal context. That means it remembers not just what happened but what relative to other things. A memory of laughter under golden light, a moment of silence after a long cry. The brain doesn't just record facts, it records feelings, impressions, sequences, time. For the mind is not a straight line. It is a story, and stories, as you know, need rhythm. They need pacing, tension, release. Your body tells stories like this all the time. The rise and fall of a fever, the cycle of a dream, the return of a hunger you thought had passed. These are not isolated events. They are chapters, layered across your senses, unfolding in time. So what happens when you disrupt this rhythm completely? What if you left gravity, left light and dark behind? What if your body was asked to adapt to time without the usual cues? That's what astronauts face. Aboard the International Space Station, the sun rises and sets every 90 minutes. Day and night become meaningless. There's no gravity to signal direction, no horizon to ground you. Without intervention, the body begins to drift. Sleep patterns fracture, digestion falters, cognitive function slows. The internal clocks, once so synchronized, begin to fall. To prevent this, space agencies engineer artificial rhythms. Lights are adjusted to mimic dawn and dusk. Schedules are enforced. Exercise is mandatory. Meals are timed. But even so, the body resists. It remembers. It longs for the cues it evolved. And it teaches us something profound, that time is not an abstract idea. It is embodied. It is felt. It is lived. You are not separate from time. You are made of it. Your cells divide in cycles. Your breath flows in loops. Your thoughts ripple across synaptic networks that require milliseconds to fire. The future arrives not in calendar pages, but in the tilt of your neck, the closing of your eyes, the shift in your chest as you fall. Tonight, as your breath softens and the sulks begin to wander, notice how the body slows, not because you told, but because it remembers. It knows that rest is not a pull from time but a deeper way of entering it. And so without trying you return to the rhythm, to the clock that needs no ticking hand, to the silent intelligence that has always known when to begin again.
Before time was measured in seconds and minutes, it was measured in shadows. You would stand in the warm hush of morning light, watching how it fell across stone and sand, how it stretched and shifted, slow as breath. The shadow of a tree, of your own body, would arc across the day like a hand sweeping through the sky. This was time in its oldest form, a visible rhythm, born from light, requiring no numbers to understand. It was the earth speaking softly to itself through the angle of the sun. Long before modern clocks, time lived in the way morning dew dried from leaves, in the length of twilight, in the hunger that came before dusk. People didn't ask, "What time is it?" They asked, "How long until the tide returns? How many shadows until the stars appear?" This way of knowing was relational. Time wasn't a thing to control, but something to witness, something to feel. The first humans who carved marks into stone or arranged sticks in the ground weren't trying to dominate time. They were trying to stay in tune with it. Sundials, perhaps the earliest clocks, did not tick or chime. They waited. A single stick in the soil could cast a long line that shifted through the day, tracing the slow motion of the cosmos across the earth. You could see time move, not hear it, and in that slowness there was something deeply comforting. Later, water clocks appeared, bowls with tiny holes that allowed a slow drip, counting moments drop by drop. Candle clocks, too, burned down in steady rhythms. These early instruments didn't promise precision, they promised presence. You watched, you waited, and in that waiting you were aware, not rushed, but anchored. It wasn't until the mechanical age that time became sharp. Gears, springs, pendulums, all working together to create the illusion of perfect order. With these inventions came a new kind of time. Uniform, relentless, exact. You could divide it, sell it, waste it. Time became currency. Factories ran by the hour. Schools began at 8. Trains departed at 9. The human day, once governed by sun and sleep, now bowed to a machine. And yet, even in this new age of ticking precision, the old rhythms never vanished. Your body didn't change its clock. It still responded to light, to hunger, to emotion. It still moved in cycles. The mechanical clock may have ruled the world, but your breath remained wild, untamed. Still, the human desire to measure never ceased. When pendulum clocks weren't accurate enough, we turned to quartz. When quartz vibrated too erratically, we built atomic clocks, machines so precise they would not lose a second in millions of years. These clocks don't rely on sunlight or gears. They rely on the vibration of atoms, usually cesium-133. Billions of oscillations per second, steady as the pulse of the universe itself. But even these perfect clocks revealed an unsettling truth. Time isn't the same everywhere. When two atomic clocks are placed at different altitudes, or move at different speeds, they fall out of sync. One ticks slower, one ticks faster, and not by much, perhaps a fraction of a nanosecond. But the difference is real, measurable. It means that time is not fixed. It bends, it stretches, it responds to motion and gravity, it listens to the universe, and changes its pace accordingly. This idea, that time is flexible, was one of the great revolutions of science. It didn't arrive easily. For centuries people believed time was absolute, that it ticked the same for everyone, everywhere. But as experiments grew more precise, that belief began to crack. If you stand at sea level, with one atomic clock, and carry another to the top of a mountain, the mountain clock will tick slightly faster. Why? Because gravity is weaker at higher altitudes, and according to Einstein's general relativity, weaker gravity means time moves faster. A tiny shift, imperceptible to you, but undeniable to the universe. And it doesn't end with height. Speed matters too. When you move quickly, especially near the speed of light, time slows down for you compared to someone at rest. This is called time dilation, and it means that someone on a speeding train or spacecraft experiences time differently than someone standing still, not just in theory, but in real, testable ways. Even GPS satellites which orbit Earth and help us navigate our streets must account for these effects. Their clocks tick slightly faster due to their altitude and speed. If we didn't correct for this, your phone's map would lead you miles off course. Every time you follow a digital route, you are trusting a system that accounts for time not being equal, a network of clocks that whispers, "Time bends here." All of this might seem abstract, but it carries a quiet poetry. It means that time is not a tyrant, but a dancer, moving differently depending on where you stand, how fast you travel, how deep you feel gravity's pull. Time listens to the shape of space, to the motion of stars, to the spin of black holes. It is not rigid, it is responsive, and perhaps on some level, your body has always sensed this. Even before science gave it language, your breath knew that time flowed differently on the mountaintop. Your muscles understood the drag of exhaustion after a long flight. Your heart responded to the rush of movement, to the hush of stillness, not by measuring seconds, but by living them. So now as you lie in bed, soft beneath the weight of your blanket, you can let go of the ticking. You can remember that time is not a line, but a landscape, a field that stretches and curves. And in this moment, in this breath, you are not behind or ahead. You are exactly where you are meant to be. And though clocks may try to define it, the truth is time doesn't live in machines. It lives in you. There is something haunting about the desire to make time stand still. Maybe it's the way memories slip from your fingers, or the way childhood fades into photographs, or the way moments you swore you'd never forget begin to soften at the edges. And so, somewhere in your past, or perhaps in the distant past of your species, someone must have wondered, what if time didn't have to move? What if you could hold it still, just for a while? From that longing came invention. Sundials gave way to gears, shadows turned into ticking hands, and humanity, ever persistent, began trying to trap time. Not in a cruel way, but in a hopeful one, as if you could name the moment, pin it to a number, and keep it from drifting away. It is 3:41 p.m., you say, as if that means something more than the warmth on your cheek, or the silence between words. But time, as it turns out, does not want to be captured. It resists the cages we build for it. Even our most careful inventions, our most exact machines, are still subject to the quiet rebellions of the universe. Consider the pendulum. For centuries it was the symbol of consistency. With each swing it seemed to echo the very heartbeat of time. Galileo saw it in the swaying of a chandelier, and imagined something pure, something eternal, and for a while it worked. Clocks were built, towers rang their bells, people organized their lives around the steady beat of a swinging weight. But even the pendulum was flawed. It swung differently at different altitudes. Temperature changed its length. Humidity thickened the air. The earth itself, in its rotation, tugged subtly at its rhythm. Time, even then, refused to stay fixed. So we made better clocks, more precise, more insulated from the whims of the world. We turned to springs, to quartz crystals, to the vibration of electrons. We measured time in frequencies, instead of falling sand. And yet the closer we looked, the stranger things became. Because the truth is, time isn't a machine. It's a consequence, a side effect, a result of motion and energy, and perspective. When you dig into the foundations of physics, you find that time doesn't sit still like a ruler on a desk. It stretches, it compresses, it responds to the fabric of space itself. Einstein's special theory of relativity told us this in the early 1900s, and it changed everything. Before that, time was assumed to be absolute, the same for everyone, everywhere, but relativity suggested that time is woven into space, and together they form a single fabric, space-time. And this fabric can bend. If you move quickly, especially close to the speed of light, your experience of time changes. From your perspective, everything feels normal, but to someone watching from a distance, your clock ticks slower, your heart beats slower, your aging slows. This isn't fantasy, it's been tested again and again. Imagine two clocks, perfectly synchronized. One stays on Earth, the other is placed aboard a jet, traveling around the world. When the clock returns, it is behind. Not metaphorically, measurably, by billionths of a second, yes, but behind nonetheless. Time has passed differently. The faster you go, the slower your time flows, relative to someone who stayed still. Now imagine extending this to extremes. A spaceship traveling at 99.9% the speed of light. On board perhaps a single year passes, but back on Earth, a decade unfolds. A child grows up, cities change, light from distant galaxies shifts in the sky, and yet for the traveler, it all happens in a blink. Time, it seems, listens not to clocks, but to motion, and it's not just speed. Gravity, too, has its say. General relativity, Einstein's follow-up, revealed that massive objects warp space-time. The more mass, the more curvature, and the more curvature, the slower time flows near it. This means that time ticks slightly slower at the base of a mountain than at the peak. It moves more slowly near Earth's surface than in orbit. It barely ticks at all near a black hole, but we'll get there later. For now, think of what this means. The idea of universal time, of a single cosmic clock, begins to unravel. Time is no longer the same everywhere. It is not a shared drumbeat. It is a pattern of countless rhythms, all slightly different, shaped by motion, by mass, by location, and yet we still try to hold it. We still build machines to keep time, atomic clocks that vibrate billions of times per second, using the precise energy transitions of cesium or rubidium atoms. These clocks are marvels. They lose less than a second in millions of years, and still they are not perfect. When moved, when accelerated, when placed in different gravitational fields, they shift, which means that time at its core is not mechanical, it is relational. It depends on context, on where you are, how fast you're moving, how deeply gravity tugs at you. This is a truth both unsettling and beautiful. Unsettling, because it means there is no single now. Two people in different places, moving at different speeds, do not experience the same present. Your now may not be mine. Every moment is personal, local, shaped by physics and perception, but beautiful too, because it means that your experience of time is unique. Your moments, the ones you feel in your chest, in your breath, in your memories, are not shared by anyone else in exactly the same way. Time becomes a fingerprint, a signature, a quiet unfolding that belongs to you alone, and maybe in the end, this helps us see why the desire to make time stand still never truly works, because time isn't a thing outside you. It's something you move through, something you carry, something that reshapes itself as you change. To stop time would be to stop yourself, your breath, your heartbeat, your thought. Instead, maybe the goal isn't to stop time, but to slow down enough to feel it, to step outside the rush of numbers and schedules, and into the deeper rhythm beneath, the one you've always known, the one that listens to breath, to silence, to wonder, because time does move, and yet in moments like this, soft, quiet, unmeasured, it also seems to pause. You've always been told that clocks are reliable, that they are neutral instruments, marking time with quiet authority, without emotion, without bias, but even the most perfect clock can be deceived, not because it is broken, but because time itself refuses to be absolute. When we push the boundaries of speed, or stand too close to gravity's deep pull, the ticking betrays us, and in those betrayals, we begin to see a deeper truth.
The universe doesn't like perfect clocks. It never did. The idea of a perfect clock, one that ticks uniformly, no matter where it's placed, no matter how fast it moves, is a fantasy from a simpler time. For centuries we believed that such a clock was possible, that time was like a river flowing evenly across every shore, that a second here was the same as a second anywhere else. But then we began to look more closely, to listen more carefully, and the river revealed its currents. Atomic clocks, the most precise instruments ever built by human hands, were our attempt to answer time once and for all. They used the oscillations of atoms, the natural vibrations of cesium or hydrogen, to define the second. These vibrations are consistent, unfazed by weather or wear. For a while it seemed we had finally caught time, that we could freeze it, measure it, trust it completely, but the deeper we went, the more things began to shift. When one atomic clock was kept on the ground, and another placed aboard an aircraft or satellite, they no longer agreed. One ticked slightly slower, the other slightly faster, not by accident, but by design, by the laws of the universe itself. These weren't glitches, they were revelations. The faster a clock moves, the slower it ticks compared to one at rest. The higher it sits in a gravitational field, the faster it ticks than one below. This isn't science fiction. It's been tested over and over, in planes, in rockets, in mountaintop observatories, and space-based laboratories, and each time the universe whispered the same secret: time is relative, and perfect clocks do not exist. This revelation rewrote everything we thought we knew. It forced scientists to redefine the second, not as a universal truth, but as something local, dependent on conditions, on frame of reference, on context. The clock on your wrist, the one in a satellite, the one ticking quietly in a lab across the globe, none of them are truly synchronized, not in the deepest sense. They may agree to within billionths of a second, but the truth lies in the difference, and those differences matter. They matter more than most people realize. The GPS system in your phone, for example, works because it can measure how long signals take to reach you from satellites in orbit. But those satellites are moving quickly, and they are high above the Earth's surface, where gravity is weaker. Their clocks tick faster than clocks on Earth. If we didn't account for that, if we pretended time was uniform, your GPS would be off by kilometers, every day, every use. So engineers account for relativity. They write equations that correct the clock. They acknowledge that time bends, shifts, distorts, not in some metaphorical way, but in the real math that guides our daily lives. The very idea of knowing where you are, of navigating the world, depends on understanding that time is never the same, from one point to another, but the implications go even deeper. If time is not fixed, then neither is the story it tells. Imagine two twins, born together, one stays on Earth, the other boards a spacecraft that travels near the speed of light, loops around a star, and returns. According to physics, the traveling twin will have aged less. Their clock, their body, their cells, will have experienced fewer seconds. It is not a trick. It is not a metaphor. It is what happens when you move quickly through curved space. This is called the twin paradox, and it is one of the strangest, most beautiful consequences of time dilation. The two twins are not separated by distance, but by experience. One has lived through more time than the other. Their bodies remember different lengths of history. Their clocks no longer match, and yet they began together. It makes you wonder how many other clocks in the universe have drifted apart. How many stars, spinning alone in distant galaxies, are experiencing time at a different rhythm than us. How many civilizations, if they exist, might be living in fast time, or slow time, or something else entirely. The idea that time is flexible doesn't mean it's meaningless. It means it's alive. It means that time listens to gravity, to velocity, to mass and motion. It means that the fabric of reality is not rigid, but responsive, that the universe itself moves not in perfect order, but in harmonic complexity. And perhaps that's why perfect clocks are impossible. Because perfection implies sameness, uniformity, And time has never been that. It is difference. It is variation. It is the pause between two breaths that feels longer than the one before. It is the dream that lasts a second and feels like an hour. It is the space between lightning and thunder, and how your heartbeat changes while you wait. Time is personal. It doesn't care for our definitions. It doesn't obey our schedules. It pulses through galaxies, drips from stars, slows beside black holes, and stretches across the space between atoms. It exists in the turn of your head, in the rise of your chest, in the way silence settles in a room just before sleep. And when we build clocks, no matter how precise, we are not capturing time, we are merely interpreting it, through our own narrow lens. We are building instruments, not to trap the universe, but to dance with it, to say, I see you, I feel you, I know you are moving, even when I try to hold you still. So tonight, as you rest here, feel the quiet rebellion in your own body, the tiny ways your pulse changes when you remember something soft, the way your breath stretches when you sigh, the way time feels thicker when you are still. The universe may not like perfect clocks, but it loves rhythm, and you in your quiet unfolding are a part of that rhythm, not measuring time, but being it.
What if time could stretch like cloth? What if the seconds you know, the ones that tick reliably past your wristwatch, or hum gently in the background of your day, could lengthen or compress like threads being pulled by unseen fingers? This is not a question meant to confuse or bewilder. It is a doorway, soft, slow, and slightly ajar, into one of the most transformative ideas ever offered to the human mind. An idea that changed everything we thought we knew about motion, space, and the flow of time. You begin to feel it not in numbers or diagrams, but in sensation. The feeling that not all seconds are created equal, that a moment of pain lasts longer than a moment of laughter, that time moves like water fast in some places, slow in others. What Albert Einstein did over a century ago was not just math, it was poetry in physics. He suggested that time itself, the thing we believed to be rigid and absolute, could bend, could twist, could stretch like cloth in the wind. At the center of his theory was a simple, stubborn truth. The speed of light never changes. Whether you're standing still, racing in a train, or floating in deep space, if you measure a beam of light, it will always travel at the same speed. This idea, so elegantly strange, meant that something else had to give. If light could not adjust its pace, then our experience of space and time had to adjust instead. To protect light's constancy, time had to become flexible. Imagine this: a beam of light bounces between two mirrors inside a moving train. To someone inside the train, the beam travels straight up and down, but to someone watching from outside, the beam follows a longer diagonal path because the train is moving. If the speed of light is the same for both observers, then time itself must move more slowly for the person inside the train. The light takes longer to complete its journey, not because it moves slower, but because time stretches to make the math work. This isn't just theory, it's been proven. With atomic clocks on planes, in satellites, in laboratories around the world, time stretches for those in motion. But the effect is so slight at everyday speeds that we don't notice it. Only when speeds approach the speed of light, only when motion becomes immense, does time stretch in a way that becomes visible, even tangible. So yes, time can stretch like cloth, but not in the way fabric frays or tears. It stretches smoothly, silently, according to rules as delicate as they are precise. Imagine a vast sheet of linen hung in the wind. Motion causes it to ripple, to pull. If you moved fast enough, the fabric of time beneath your feet would ripple too. You wouldn't feel it, not at first, but step off the cloth, return to someone standing still, and you would see the difference. A few minutes for you, years for them. This is the world Einstein invited us into, a universe where time is not universal, where your clock and mine, though built identically, may not agree, where now for me might not be now for you. Time becomes personal, shaped by how we move through space. It becomes a thread woven into our own path, not shared by all, but curved gently by our velocity. And space too feels the bend. In Einstein's world, space and time are not separate. They are one, a single soft fabric called spacetime. Move through space, and you affect time, fall into gravity's pull, and time slows down. The greater the mass, the deeper the well, the more space and time bend. What was once geometry becomes physics. What was once fixed becomes fluid. This was not easy to accept. People resisted. After all, how could something as dependable as time, the very structure of experience, be so flexible? But experiment after experiment confirmed it. Not in dreams but in data. Time dilates, time shifts, and with that realization came a quiet humility. We are not standing on a firm grid of unchanging seconds. We are floating in a sea, and the currents move differently depending on where you are, how fast you're going, and what you're near. The cloth stretches, and we stretch with it. But here's where it becomes more than theory. This stretching of time is not just about clocks or particles or spaceships. It's about you. Because your body, your thoughts, your memories, they are all built on time. Your heartbeat, your breath, the aging of your cells, all are clocks in their own way. And if time stretches, so does your life, so do your dreams, so does your perception of the world. If you were to board a ship and travel near the speed of light, your body would experience time slowly. Your heart would still beat in its usual rhythm. Your thoughts would still come as they always do. But when you returned, everything else would have changed. People would be older, events would have passed. You would feel untouched, while the world would have moved on. This is not fiction, this is physics, and it speaks to something tender, the idea that time is not just motion through space, but motion through relationship. Your time is tied to your path, and that makes it precious, unique, yours alone. So lie here now, in stillness. Feel the softness of your pillow, the weight of the blanket, the quietness of your room. Know that even now, even in this pause, the fabric of time moves around you. It stretches, it bends, it curves, not just far away, not just in space, but here around your breath, around your life. Time is not ticking, it is unfolding, and you, as you drift, unfold with it. There's a strange kind of magic in watching a train disappear into the horizon. From a platform, you see it move away, steady, constant, rhythmic. But if you were inside that train, leaning gently against the window pane, everything would feel still, the world would blur, but your seat would remain calm, your body, your breath, your heartbeat, all unchanged. The feeling of motion becomes something subtle, something relative, and this is where our understanding of time begins to bend, in ways most never expect. Imagine two people, one remains on the platform, the other boards the train. The train begins to move, not slowly, but at a speed approaching light. At this velocity, physics begins to behave differently. Time, once firm and familiar, begins to stretch. But here's the curious part, neither person feels it. For the passenger, time passes as always. A heartbeat takes a moment, a breath lasts the same, but from the perspective of the one standing still, the passenger's time appears to slow. This is not metaphor, it is the essence of special relativity, a theory born not in fantasy, but in mathematical truth. As the train moves faster, the ticking of the passenger's watch, the pace of their thought, even the aging of their skin, all appear to slow relative to the observer. The faster the train moves, the more pronounced the effect becomes. At the speed of light, time for the traveler would seem to stop entirely, at least to those left behind. But for the traveler, nothing feels unusual. The seconds pass with comforting consistency. They may sip tea, read a book, dream quietly in their seat, all without knowing that their now is drifting away from everyone else's. This is the quiet brilliance of Einstein's insight, that simultaneity, the idea of two things happening at the same time, is not absolute. It depends on motion, on perspective. It's easy to believe that time is a shared river, flowing the same for all, but relativity teaches us that each person carries their own current. When you move, even a little, you bend that current slightly. When you move fast, unimaginably fast, the bend becomes profound. Two people can share a beginning, depart from one another, and return to find their lives no longer aligned. This has been confirmed not only with atomic clocks flown in jets, but with particles called moles, which are created when cosmic rays strike Earth's atmosphere. These particles should decay almost instantly, yet because they move at near light speeds, they live longer, from our perspective, than they should. Their internal clocks slow down as they race through our sky. They survive their journey not through luck, but through the distortion of time. Let's return to our imagined train. Suppose a flash of lightning strikes both ends of the train at the same time. To the observer standing on the platform, the strikes are simultaneous, but to the person on the moving train, who is traveling toward one strike and away from the other, the flashes will not seem to happen together. Light takes time to reach them, and because they are moving, they meet one flash before the other. Two realities, both valid, both correct. This is the unraveling of the idea of universal now. We often think of time as a canvas stretched behind everything, unchanged by our actions, but relativity shows us it's more like fabric, pulled and shaped by motion. There is no single now, no shared moment across the universe. Every point in space carries its own ticking heart. What you call the present is not a universal truth, it's a local experience. This can be hard to accept. We're taught from childhood to think of time as one great ticking metronome shared across oceans, across stars. But time, like light, travels in context. Your watch, your memories, your age, they are all entangled with how you've moved through the world. And when you move faster, time doesn't stop, it dilates. Like a rubber band stretched between two fingers, it lengthens. What feels like a second to you may look like two to someone else. The further and faster you travel, the wider the stretch, and yet to you, nothing feels different. This is the paradox. Time never betrays you from the inside. It only shifts when viewed from somewhere else. This doesn't just reshape physics, it reshapes meaning. Imagine returning from a journey where only a year has passed for you, but 20 years have passed on Earth. You've lived less, aged less, changed less, but everyone you knew is older. Some may be gone. The world may not recognize your face. You've carried time with you like a private bubble, intact, untouched, but that bubble has drifted far from everything you left behind. Time dilation, then, is not just a scientific curiosity, it is an emotional weight, a truth that reveals the fragility of connection. If time can stretch between friends, between siblings, between lovers, what else might it stretch between? What do we lose when our clocks fall out of sync? And yet within this truth, there is something beautiful. You are not bound to a single thread of time, you shape it, gently, with your motion, with your speed, with your gravity. Time becomes a fabric, yes, but one that ripples with your presence. You are not just moving through time, you are curving it around you. As you lie still now, there is no train, no lightning, no clocks in motion, but there is breath, there is awareness, and there is a quiet personal unfolding, your version of now. It is shaped not by science, but by softness, and yet the science agrees.
This moment, this stillness is yours alone. No one else in the universe is experiencing this second exactly as you are. So let it stretch, gently, let it hold you like cloth warmed by the sun. In this breath, in this pause, you are both the passenger and the platform. Time moves for you, and around you, and within you. It begins as something simple, a beam of light, steady and sure. It moves through the universe with unwavering purpose, not speeding up, not slowing down, not bending to the will of anything or anyone. In all directions, in all frames of reference, light remains loyal to its speed, and yet this unshakable rule is precisely what shakes the very foundations of how we understand space, time, and the rhythm of existence. Because if light refuses to bend, then time, which once felt like the most dependable of all things, must instead. In everyday life, the speed of things is relative. You ride a bicycle down a road, and your motion depends on what you're measuring against: the pavement, the trees, the wind. If another bicycle approaches from the opposite direction, it seems to speed toward you faster than either bike is actually moving. This is how your mind works with motion. It adds, subtracts, adjusts, but light refuses these rules. No matter how fast you're moving, whether you run toward it or away from it, light always reaches you at the same speed. It's as if the universe has placed a boundary, a speed limit that can't be violated, not even by adding motion to motion. And the only way for this to make sense is to let go of the idea that time flows the same for everyone. To keep light's speed constant, something else must give. That something is the ticking of your clock. Imagine you are floating in space, far from gravity, far from movement. You hold a small flashlight and aim it forward. The beam moves away at the speed of light, exactly as expected. Now imagine another version of you, identical in every way, but this time moving rapidly through space, in a sleek spacecraft. They too hold a flashlight, and to their eyes, the beam behaves the same way, steady, fast, obedient. But here's the strangeness: despite their motion, the beam does not rush ahead faster, and so to preserve this truth, time must slow down for the traveler, not just in theory, but in every breath, every heartbeat, every blink of the eye. The faster you move through space, the slower you move through time. It's as though the universe trades one for the other, speed through space for slowness through time. This interplay between motion and time is not just abstract, it is essential. It governs satellites orbiting Earth. It corrects the signals that guide your phone. It ensures that a spacecraft on its way to the edge of the solar system sends back signals that still make sense. Without this understanding, nothing in our modern world would work as precisely as it does. Every GPS calculation, every long-distance communication, every satellite orbit relies on time being relative, on light refusing to bend. But perhaps even more astonishing is the realization that light's refusal is not a flaw. It is a foundation. It is the pillar on which the universe builds its rhythm. In holding firm, light demands flexibility elsewhere, and so the ticking of your clock becomes a soft shifting thing, no longer absolute, no longer impartial, but deeply entangled with motion, with direction, with energy. In this light, time becomes a river, with many branches, some fast, some slow, some winding gently around the contours of mass and momentum. Two clocks, identical in construction, can tick differently, simply by being placed in different paths, one moving fast, one standing still, one deep in a gravitational well, the other far from any mass, and yet both are correct in their own frames. There is no universal ticking, only context. This is what Einstein meant when he spoke of time as relative, not that time is illusion, but that it is personal, shaped by your journey through the universe. What you experience as 1 second may be a longer interval for someone else, not imagined, real physically, measurably real. And yet there's something deeply human in our resistance to this truth. We like to believe in a shared now, a single thread we all walk together, but the universe whispers otherwise. It tells us that time is layered, folded, stretched, that each of us carries our own private thread, that no two moments are quite the same, even when shared side by side. You may be lying in your room, now still, quiet, breathing gently, but even here, the earth spins beneath you. It orbits the sun, which spirals through the galaxy, which itself drifts through the cosmic web. You are never truly still, you are always in motion, and with each layer of movement, time responds. Your personal rhythm, your seconds, your minutes, your hours, are influenced by all of it, and yet it all feels seamless. Your breath doesn't falter, your thoughts arrive in order, your memories unfold in sequence. This is the wonder of consciousness, to take the flexible, complex dance of time, and experience it as a smooth, unfolding story. Even as time bends around you, you remain inside it, moving forward with grace. So when scientists say that light refuses to bend, they are not speaking of stubbornness, but of a kind of cosmic loyalty. Light holds to its speed, like a thread, connecting all observers, all realities. It becomes the ruler, by which all motion is measured, and in doing so, it demands that our rulers, our clocks, our calendars, our expectations, change shape, and that is what makes this truth so beautiful. The unchanging speed of light forces everything else to become more fluid, more alive, more human. Time is not a cold mechanism, it is a living relationship, between you and the universe, between motion and stillness, between here and there. Tonight, as you lie back and feel the slow rhythm of your chest rising and falling, you are participating in that relationship. You are not just a passenger in time, you are a sculptor, shaping your own stream, carving your own current through the vast sea of space. And the light, the one that refuses to bend, watches over you, keeping its pace, guiding your journey, reminding you that even in the shifting tides of time, something remains steady.
High above the low murmur of cities, above the clouds that drift in silence, beyond the reach of birds or weather, time begins to change, not in ways you can see or hear, but in ways so quiet they almost escape our notice. As you rise, second by second, meter by meter, the clock at your side begins to drift from the one you left behind. Not by much, not in a way that would ever show up on your wristwatch, but it's there, subtle and persistent, written in the folds of space and the strength of gravity's grip. If you stood on a mountaintop with a clock, and someone else stood at sea level with the same model, synchronized to the tiniest fraction of a second, over time you would begin to pull ahead. Your clock, bathed in slightly less gravity, would tick just a little faster. The difference is minuscule, nanoseconds per day, and yet it is real. Time, it turns out, does not move at the same speed for everyone. Gravity holds more than your body. It holds your seconds too. This idea might feel impossible at first. After all, standing at the peak of a mountain doesn't feel like you've stepped into a new reality. The wind is colder, the air is thinner, the view stretches farther, but everything else, your thoughts, your breath, your memories, continues in its usual rhythm. You wouldn't say time feels faster up here, but science would. It's because of something hidden, something woven into the fabric of what we call space-time. Gravity, which you know as weight, as fall, as pull, is not just a force, it's a curvature. It bends space and time like a heavy ball resting on a soft sheet. The more mass an object has, like the Earth, or a star, or a black hole, the deeper that dent becomes. And where the dent is deepest, time slows. So when you are closer to Earth's center, deeper in its gravitational well, your time ticks just a touch more slowly than someone who lives higher up. The mountain top is not just higher in elevation, it is higher in time. a place where the grip of gravity loosens ever so slightly and seconds pass with a freer hand. This isn't a thought experiment, it's measurable. Atomic clocks, so precise they can detect differences smaller than a billionth of a second, have confirmed it. Take one to a hilltop, leave the other in the valley, and watch them diverge. They're both right, both faithful to the conditions around them, but they no longer agree. Time has chosen different paths for them, and each obeys. It's a quiet revelation, but a powerful one. Take it means that even here on Earth, time is layered. Your elevation, the place you sleep, the place you dream, shapes the rhythm of your life in ways you cannot feel. It means that our planet is not just a place, but a gradient of time, with every level ticking to a slightly different beat. Take, and when you begin to rise even farther, into the upper atmosphere, into orbit, the differences grow. On the International Space Station, astronauts circle the globe every 90 minutes, fast enough to experience 16 sunrises a day. Take their clocks, moving quickly and sitting higher in Earth's gravitational field, tick both slower and faster, depending on which effect dominates. Velocity slows their time, altitude speeds it up. The result? They age just a little more slowly than we do, fractions of a second at a time, but over years it adds up. This gentle slowing, this stretching of moments, doesn't cause pain or discomfort. It isn't something that can be sensed directly, and yet it happens inside their very cells, in the way proteins fold, in the way hearts beat, in the way DNA ages. Their time is different not because of what they do, but because of where they are. Take, and so, as you imagine them floating quietly above us, moving through sun and shadow, working and sleeping in cycles unmoored from our day and night, you begin to feel something profound. That time is not an invisible background. It is not impartial. It's responsive, alive. It listens to mass, to altitude, to speed. It listens to placement, and in that listening, it shifts its flow, which leads to a delicate question: what does it mean for time to be personal? Take, if your elevation, your motion, your position in space can shape the length of your second, then your time is yours alone. It's not universal. It's curved, cradled, stretched by the space around you. Take, and when two people part, one staying low, one climbing high, their moments begin to pull away from each other, however gently. It's a reminder that even when we share a space, we may not be sharing time, that the universe holds us in separate threads, however closely woven. And though we often speak of time as a straight line, it is more like a topographical map, full of contours, elevations, valleys. Your heartbeat ticks along a ridge, mine ticks in a fold, and we may not even realize how far apart we truly are. But this truth, strange as it is not cold. It is intimate. It reminds you that your experience, your seconds, your dreams, your memories, are not just real, but unique, that your life unfolds at a rhythm, tailored by the very shape of the world beneath you. Take, ere you breathe, the height of your bed, the gravity that presses you down, all of it quietly bending the shape of your time. Tonight, as you lie still, think of the ground beneath you, a quiet, massive curve of stone and iron, bending time ever so slightly around your body. And above you, the mountain peaks, the satellites, the stars, all ticking at their own pace, a cascade of clocks, each whispering its own rhythm, all flowing in the same direction, but never quite in sync. You are part of that cascade, a single note in a vast slow melody, and though your time is shaped by place, it is also entirely yours, a song that plays only once, only here, only now. When you think of gravity, you likely think of weight, the sensation of your body being held to the earth, of an object falling, of something pulling down. But gravity does something even more subtle, more invisible, more profound. It changes the tempo of time itself, not in the way that a storm might disrupt a schedule, or a busy day might make the hours feel short. Take no. Gravity bends time, literally and physically, like a soft current pulling moments inward. And once you begin to understand this, you see the universe not as a place where time simply passes, but as a place where time responds. Imagine a fabric, vast, silent, soft, stretched across space. This is space-time. Every mass, every planet, every star, every atom rests on this fabric, not like a marble on a board, but like a weight on a trampoline. It doesn't just sit, it sinks. The greater the mass, the deeper the well it creates. Earth creates a depression, the sun creates a chasm, a black hole becomes a bottomless pit, and as light and matter move near these wells, their paths curve, but more importantly, so does time. Where gravity is strong, time moves slowly. Where gravity weakens, time moves faster. This is not philosophy, it is physical law. Time does not keep a universal beat. It flows like a river through valleys and over hills, faster in some places, slower in others. The gravity of every object around you, no matter how small, contributes to the tempo of time, and the earth beneath your feet is the strongest player in this quiet symphony. Stand at sea level, where gravity is strongest on Earth's surface, and your clock ticks a fraction of a second more slowly than someone high in the mountains. Sleep in a basement, and your dreams unfold just slightly slower than they would in a high-rise apartment. The difference is tiny, nearly impossible to detect without the most sensitive instruments, but it exists, and it tells you something remarkable. Time is not just ticking along, it is shaped by the mass beneath you. This phenomenon is called gravitational time dilation. It was predicted by Einstein's theory of general relativity, and later confirmed by experiment after experiment. In 1976, scientists launched a hydrogen maser clock aboard a rocket and compared its ticking to a ground-based counterpart. The result, the high-altitude clock ticked faster, just as Einstein said it would. Since then, satellites, probes and spacecraft have provided consistent proof. Gravity slows time down. Even the Global Positioning System, GPS, must account for this effect. The satellites orbiting Earth carry atomic clocks that run slightly faster than those on the ground, not just because of their velocity, but because they are farther from Earth's center, in weaker gravity. If this difference weren't corrected, if the clocks were assumed to tick identically, your GPS would drift by kilometers every day. Your location would become wildly inaccurate. Every time you open a map on your phone and follow your position in real time, you are relying on corrections for gravitational time dilation. The slowness of time near Earth is not just theory, it is baked into your daily life. But beyond technology, beyond equations and measurements, lies a more poetic truth. Gravity doesn't just pull on objects, it pulls on the pace of living. Imagine being born near a massive star, where gravity is strong. From an outside perspective, your life would unfold in slow motion. A heartbeat might last longer, a blink might stretch like a moment of wind moving through tall grass. You would feel no difference. Your life would feel complete, full, ordinary, but from afar, you'd be gently lagging behind. Now consider someone floating far from all stars and planets, in the deep vacuum of interstellar space. Their gravity is nearly absent. Their time would flow slightly faster. They would age just a touch more quickly than someone near a planet. Over years the difference might grow. Two people born on the same day, living equally long in their own experience, could end their lives with different amounts of time having passed in the wider universe. And this isn't just about aging, it's about perception. Imagine two friends, one at the base of a deep gravity well, like on the surface of a massive planet, and the other floating far above it. They wave to each other, send signals, compare clocks. Over time they realize they've drifted apart. The one closer to gravity experiences fewer seconds, not because they've done less or lived less, but because time itself passed more slowly. This separation creates a strange kind of solitude, not of distance but of rhythm. You begin to understand that gravity does more than anchor bodies. It anchors experiences. Tethers each moment, holding it back or letting it rush forward, depending on the shape of the space around it. And so as you walk through the world, as you climb a hill, descend a staircase, ride an elevator, you are subtly rising and falling through layers of time. Even your body participates in this gradient. Your feet closer to Earth's center experience time more slowly than your head. Over a lifetime, this results in nanoseconds of difference, but the idea itself is profound. You are stretched across time. Even standing still, you are a vertical traveler, moving from slow to fast to slow again, with every heartbeat. And all of this, all these tiny shifts, tell a greater story, that time is a shape. It bends and curves. It wraps around stars and sinks into planets. It flows uphill and downhill, depending on the terrain of mass and motion. You are not floating in time, you are embedded in it, like a pearl in water, and the water moves. As you lie still, and let your thoughts soften, you may feel that gravity, that gentle pull toward the earth, toward the ground beneath your bed. But know this, it is not just holding your body, it is cradling your time, slowing it, shaping it, allowing each second to arrive a little more gently. You are not lost in time, you are being held by it, and the weight you feel, that constant companion we call gravity, is more than just force. It is the shaping hand of the cosmos, sculpting not only space, but the very rhythm of your life. Hundreds of kilometers above your head, something extraordinary happens every second. Quiet, persistent, invisible. A network of satellites glides through Earth's orbit, their paths precise, their missions constant. These are the satellites of the global positioning system, the invisible scaffold beneath the world's maps, routes, and navigation. They are machines, yes, but they are also timekeepers, and not just ordinary clocks, ticking in isolation. They are participants in a grand cosmic experiment, one that proves with every orbit that time itself is not what it seems. Each GPS satellite carries an atomic clock. These clocks are among the most accurate ever made, beating out seconds by counting the vibrations of cesium atoms with a precision so fine that they lose less than a billionth of a second over days. Yet despite their sophistication, despite their perfection, these clocks cannot simply be trusted to tick at the same rate as clocks on Earth, because in orbit, time runs differently. Two effects are at play. The first is speed. The satellites move quickly, about 14,000 kilometers per hour, and this velocity causes their time to slow down, just as Einstein's special relativity predicted. This is time dilation due to motion. The second effect, though, is the height at which they orbit. Far from Earth's surface, the pull of gravity is weaker, and according to general relativity, this causes time to speed up. These two effects oppose each other. Motion slows the satellite's time, while distance from Earth speeds it up. And here's the astonishing part. The gravitational effect is stronger. The net result is that GPS satellite clocks tick faster than those on Earth, by about 38 microseconds per day. That may not sound like much, but if uncorrected, it would cause navigational errors of nearly 10 kilometers every single day. Within minutes your phone would guide you not to your front door, but to the wrong neighborhood, the wrong city, the wrong coastline. Precision would collapse, maps would unravel. So scientists apply corrections. They program the satellites to account for relativistic time distortion. Every time you follow a blue line across your screen, every time you receive a delivery, track a flight, or locate a hiking trail, you are benefiting from a quiet, continuous accommodation of the fact that time moves faster in the sky. This is where relativity stops being a concept of blackboards lecture halls, and becomes a daily companion. Without adjusting for time dilation, our entire navigation system, and much of our digital infrastructure, would be useless. It is one of the few moments where the abstract world of space-time curvature collides directly with the concrete world of humans, roads and routines.
and it reminds you that the universe, in all its strangeness, is not far away. It is under your feet, over your head, inside your pocket. And yet, even with these corrections, GPS remains a fragile thing, a system dependent on synchronization across dozens of machines, each gliding through slightly different gravitational fields, each experiencing time in their own way. Engineers must constantly monitor and recalibrate, ensuring that each satellite's clock remains in harmony not only with Earth but with the others, a ballet of time across emptiness. It's a testament to how complex and personal time truly is. We once thought of it as absolute, something shared, impartial, smooth, but GPS shows us that time is local, that every clock exists within its own space-time, that there is no universal tick, only echoes of motion and mass, whispering across distances. Now pause and think of the satellites themselves. Imagine one floating in the darkness, Earth's curve beneath it glowing in the soft blue of atmosphere. It races through night and day, sunrises and sunsets blurring into one. Below, cities flicker, mountains sleep, people walk through lives unaware of the machine tracing their paths. But above, the satellite watches, listens, counts, each second, slightly faster than yours, each vibration of its clock, a tiny edge forward in time, and you, standing on the ground, are tied to this dance. You carry a device that catches those signals, measures delays, calculates your location, and embedded within that calculation is a truth far deeper than any map. Time bends, and we must bend with it. It's easy to take this for granted, to open an app, see a dot appear, follow a route, but inside that dot is a quiet conversation between heaven and earth. A conversation shaped by light speed signals, orbital velocities, and the subtle warping of time by mass and motion. A conversation that never stops, even when you sleep. This technology did not arrive by accident. It was built, tested, doubted, confirmed. It emerged from a long line of experiments, from clocks on mountains to planes flying across oceans. Every piece of it rests on the idea that time is not the same in all places, that altitude changes pace, that motion shapes rhythm, that we must account for difference if we are to stay together. And so, in this small persistent miracle, your phone telling you where you are, lies the universe's gentle correction. It reminds you that your time is not the same as the time above you, that every height, every orbit, every frame of motion carries its own tempo, and that if we wish to build systems that endure, that guide, that connect, we must listen to the subtle shift of seconds. Tonight, as you lie in stillness, far below those silent satellites, know that they are ticking just a little faster than you, that they are floating in the thin edge where gravity loosens and time flows more freely, and that in some way your body and theirs, your seconds and theirs, are joined in a continuous conversation, tracing lines across the sky, weaving a map not only of space, but of time itself.
16 times a day, the sun rises and sets for those floating far above the earth. Not because the world is turning faster, but because they are circling it with astonishing speed. Aboard the International Space Station, astronauts experience time not as a long, steady arc from morning to night, but as a rapid sequence of light and shadow, each day compressed into 90-minute loops. And with this rhythm comes a new kind of relationship to time, one that feels both familiar and foreign. Aboard a spacecraft, time is not simply counted, it is felt, distorted, restructured. It is lived differently, moment by moment, orbit by orbit. Imagine waking to sunlight, not once, but 16 times in 24 hours. The light floods the cabin, piercing the stillness, and then just as quickly, it vanishes into night. Outside the window, the curve of the earth appears and recedes, oceans and continents swirling by. Your body, trained for the cadence of a single sunrise, struggles to adjust. Your eyes, your skin, your cells, all conditioned by Earth's slow turning, now float in a reality that cycles too quickly, where dawn and dusk lose their traditional meaning. To the astronauts aboard the ISS, this becomes normal. But normal here is not what it is below. Inside the spacecraft, artificial schedules are imposed to maintain some illusion of Earth time. Lights are dimmed according to terrestrial nights, meals follow familiar clocks, and sleep is regulated not by the sun, but by programming. Still, the body resists. It feels the absence of true gravity, of sunrise that stretches, of night that deepens. It senses the loss of the planet's rhythms, those ancient invisible pulses we carry in our blood. And the body is wise. It remembers. Your circadian rhythm, developed over millions of years, relies on the rotation of the Earth, a consistent 24-hour cycle that governs hormones, metabolism, and mood. In space, that rhythm is disrupted. The rapid fire of sunrises sends confusing signals. Melatonin, the sleep hormone, no longer rises reliably. Cortisol, the stress hormone, begins to spike irregularly. Astronauts experience insomnia, fatigue, emotional shifts. They're not just floating in space, they're floating in time that no longer fits, yet somehow they adapt. The human mind, despite its anchors to rhythm, finds ways to reorient, through routine, through structure, through the conscious imposition of order. The brain reshapes its experience. The crew learns to sleep in darkness, created by drawn blinds and dimmed lights. They exercise, not just to preserve muscles in zero gravity, but to reset their internal clocks. They learn to feel time, not through sun and shadow, but through ritual, through trust. Still, even when the brain adjusts, the physics does not relent. Then from Narration ordered, they has not just to preserve muscle belay. The ISS orbits at roughly 28,000 km per hour, fast enough for time dilation to occur. From our perspective on Earth, the astronauts' time passes slightly slower. Their seconds stretch, their clocks fall behind, not by much, just a few milliseconds over 6 months, but real nonetheless. Their bodies age a touch more slowly than ours. They return to Earth with less time passed in their bones. It's a strange reversal. Though they experience more sunrises, their time has moved more slowly. Though their lives seem to spin faster, their clocks tick behind. This contradiction is one of the quiet wonders of relativistic time. It's not felt in the moment, but it's there, nestled in the data, in the numbers. A whisper between seconds, a delay too small for the senses, but too large to ignore. And so, to live in space is to live in a paradox. You are surrounded by constant change, light and dark cycling. Every 90 minutes, the Earth spinning below you, the stars holding still in the infinite distance, and yet your time, relative to others, moves just a little more slowly. You are aging, yes, but less. You are witnessing more, but within a stretched clock. It is a life at once accelerated and delayed. And this affects more than sleep or biology. It touches the soul, because time is not just a measurement, it is memory, emotion, experience. To have your time distorted, even gently, is to feel unmoored. Astronauts often describe looking at the Earth as a spiritual experience, a sudden realization of smallness, of fragility, of unity. But perhaps what they're really feeling is the slip of time itself, the awareness that they are no longer in sync with the world they left behind. Imagine sending a message to a loved one, knowing your time and theirs are slightly apart. Imagine looking down on the places you once stood, knowing they now belong to a rhythm you no longer share. This is not loneliness in the traditional sense. It is a kind of temporal solitude, the quiet realization that your seconds have become private. And yet in this solitude, there is beauty, because to live in orbit is to glimpse time from outside the system, to feel its elasticity, to witness firsthand that time is not fixed, that it bends to motion, to gravity, to place. And through that understanding, you begin to appreciate the seconds you do have, the ones that pass unnoticed on Earth, the ones you rush through, the ones you forget to cherish. Space teaches that time is a gift, precisely because it is not guaranteed to move the same for everyone, and that even a millisecond of difference can hold meaning, can tell you something about where you are, and how far you've come. Tonight, as you lie beneath the sky, know that above you, a handful of humans orbit in silence, their clocks ticking just a breath behind yours. Their dreams may come at different intervals, their mornings may arrive too often, but they too are part of this vast story, the story of time that moves, bends, stretches, and holds us all. Time without gravity is not simply lighter, it is stranger. For all your life, you've known gravity as something that grounds you, not only in space, but in routine. You wake, you stand, you stretch, you feel the slow pull downward, as your body remembers what it means to be upright. It is gravity that teaches your muscles tension, and your bones alignment. But more than that, gravity gives you orientation in time. It provides a reference point, something firm to measure each moment against. So when you leave gravity behind, you do not just float in space, you begin to drift through a time that no longer feels anchored. Inside a spacecraft, gravity vanishes not because the force disappears, but because everything falls together. You and the vessel and the objects around you are all in free fall, perpetually falling toward Earth, but never hitting it. This creates a state of weightlessness, and in that suspension, the body begins to lose its familiar context. Your feet no longer feel the ground, your head no longer senses up from down, and slowly, almost imperceptibly, your inner clocks begin to shift. Your sense of time has always been linked to movement. Walking across a room, cooking a meal, getting dressed, all involve sequences, transitions, the passing of one moment into the next through physical interaction. In zero gravity, those sequences change. Motions become slower, more deliberate. You no longer reach and grab with the same precision. You must float, adjust, glide. Everything is slower and stranger. Even a simple turn of the head takes on new meaning when it no longer triggers the gentle tug of Earth's pull. This slowness affects more than action, it changes perception. Studies have shown that astronauts often feel disoriented in space, not just because of the altered visuals, but because their internal sense of time becomes unmoored. The feedback loops the brain uses to track duration, like the effort it takes to move, or the shift in light as you walk through space, are disrupted. Tasks that would feel fast on Earth feel longer. Some moments seem to stretch, others vanish altogether. Time stops feeling linear. It becomes a fluid, floating experience. Sleep, too, begins to change. Without the natural rhythm of gravity-assisted fatigue, without a clear sense of down to signal rest, your body finds it harder to wind down. Astronauts often report shorter sleep cycles, lighter sleep stages, and more frequent waking. Their bodies are caught in a mismatch between internal rhythm and external cues. Even with scheduled nights aboard the spacecraft, and with melatonin supplements or sleep masks, the sensation of true rest becomes elusive, and the effects ripple deeper. Metabolism shifts, the body begins to reallocate resources. Muscles atrophy, because they are no longer needed to resist gravity. Bones lose density, fluids redistribute, pooling in the upper body, and causing faces to puff, eyes to blur. The heart begins to change shape. Every system that evolved under gravity begins to adapt to its absence, and in that adaptation time feels different. It is not simply passing, it is rewriting the rules under which the body experiences itself. You might think that with less stress from gravity, the body would feel relaxed, but it's the opposite. The body is used to working against gravity, and that resistance is a kind of feedback, an affirmation of where you are in the world. Without it, the body loses reference. Posture fades, movement becomes less instinctive. You have to think before you move, and even then the result is often slower, more tentative, and with each shift in motion, Your brain recalibrates its expectations of how long something should take. This is what makes time in space not only slower in a relativistic sense, but stretched in a personal one. Your thoughts take more effort, your feelings become distant, emotional regulation becomes more difficult. Without gravity to pull you toward the ground, it feels, at times, like your mind begins to float too. You are still thinking, but with more pauses. You are still living, but inside a slightly lengthened second, and perhaps the most surreal aspect is how normal it begins to feel. After a few weeks, the body begins to forget Earth. It learns how to float. It learns how to sleep with Velcro straps, and how to laugh in slow motion. And in this new normal, time becomes less about minutes and more about cycles, work cycles, exercise routines, scheduled video calls. The clock still exists, but it is not felt in the same way. It is followed, not inhabited. This raises an existential question. What is time when you are no longer touching anything solid, when your feet do not plant, when your steps do not echo, when your body does not fall into gravity's embrace? Is time still the same thing, when there is no resistance, no pressure, no friction to define it? Perhaps time in space teaches us that gravity is more than a force. It is an editor of experience. It punctuates your actions. It places limits on how quickly you can move, how firmly you can rest. It gives texture to your memories. Without it, time is still there, but it becomes translucent. You must reach for it differently. You must learn to feel it not as something that presses against your life, but something that slips beside it. Tonight, as you rest in gravity's arms, as you feel the familiar weight of your body against your bed, let yourself notice how grounding that feeling truly is. Let your breath rise and fall, not just in rhythm, but in response to the gentle downward pull of the world. And know that above you, in a quiet capsule, someone floats, their seconds stretched, their sleep thin, their dreams unanchored, but still ticking forward, in their own quiet suspended clock. Orbit is not silence, but it feels like it. The kind of silence that wraps around your thoughts and softens the edges of your attention. In space, aboard the International Space Station, or any other orbital vessel, silence isn't just the absence of noise, it's the absence of Earth. The hum of wind, the rustle of leaves, the distant rhythm of traffic, or the laughter coming from a nearby street, all of it vanishes the moment you're launched into orbit. And with that stillness comes a strange recalibration of time. Without the usual sounds, smells, pressures, and weights, you begin to notice the seconds in a new way. They don't disappear, but they arrive differently, softer, as if drifting alongside you. This is the quiet of orbit, not because nothing is happening, but because everything is happening at once, and in slow, smooth motion. From the window of a spacecraft, Earth rolls beneath you in magnificent silence. Its atmosphere curls in blue ribbons. Storms spiral with terrifying grace. Cities blink like neurons. And all the while, the station moves at nearly 8 kilometers per second, completing a full circle around the planet every 90 minutes. This speed, this orbit, should feel dizzying, and yet inside the cabin, it feels still. Part of the quiet is mechanical. Spacecraft are built to minimize sound. Insulation keeps the whirs of fans and electronics low. Vibrations are muffled. Movements are careful. Even speech becomes gentler. Astronauts talk in calm tones, aware of the confined space and the need for clarity. This creates a soundscape, unlike anything on Earth. One where your own breathing becomes part of the background, where a drifting pen, tapping lightly against a wall, is enough to draw your attention, where silence is not absence, but presence. And then there is the light. In orbit, there is no real night. The sun rises and sets over and over, as the station loops around the Earth, but the transitions are abrupt. Day becomes night becomes day, all within minutes. The horizon flashes with fire, and fades to black in an instant. This relentless rhythm of sun and shadow creates a surreal experience. You close your eyes during daylight.
open them into darkness, and blink again into light. It blurs the distinction between morning and evening. Your body, craving the slow golden arc of a terrestrial sunset, must instead adapt to rapid flickers, and with that adaptation, your sense of time begins to float, without gravity, without day and night, without the usual cues of motion and sound. Time becomes internal. It is no longer something you observe, it is something you carry. You begin to measure time, by tasks, by meals, by the voices from mission control, by the schedule printed on the wall. It is a linear structure imposed on a non-linear environment, but the structure works. It gives you something to hold on to when everything else drifts. Still, there are moments when the structure fades, when the schedule ends, when work is done and you are alone. In those moments, floating in your sleeping bag, tethered to the wall, your body begins to feel the vastness. You are not standing, not lying. There is no pressure against your back, no pillow beneath your head, just the soft cocoon of fabric, and the quiet knowledge that beneath you, 400 kilometers away, Earth spins on, and in that moment, time feels different, not slower or faster, but wider. It spreads. A thought that would pass in an instant on Earth lingers here. A memory unfolds more fully. A sensation, hunger, tiredness, melancholy, lasts just a little longer, as if the absence of grounding lets emotion drift with you. There's no place for it to settle, so it hovers, and your awareness of time becomes less like a ticking clock, and more like a sea. Some astronauts speak of time in space as meditative, not because they are at peace every moment, but because they are forced to be present. Everything must be deliberate. Movement, speech, attention. You cannot rush in orbit. You cannot storm through a door, or run down a hallway. Everything is gentle. Floating itself demands patience, and in that patience, time softens. Others speak of time in orbit as lonely, not because they are truly alone. They are surrounded by crewmates, in contact with Earth, monitored constantly, but because the rhythm of Earth is gone. Birthdays happen without cake, holidays without seasons. Time on Earth continues in one rhythm, while your own moves differently. You receive messages that feel out of sync. Someone says good morning, and your clock reads midnight. You feel the drift, not in days, but in meaning. And yet orbit also brings a closeness to time that is hard to find on Earth. With fewer distractions, with fewer inputs, you become aware of each moment's detail. You notice how your food tastes. You notice how your muscles respond to exercise. You feel the seconds between thoughts, between blinks, between one breath and the next. Time becomes textured. It becomes intimate. Eventually, when astronauts return to Earth, many report that time feels strange. Gravity feels strange. Noise feels overwhelming. Sunsets feel long, almost endless. The body rejoices in gravity's return, but the mind needs time to catch up. The contrast between orbital time and terrestrial time is jarring. What was once a gentle drift becomes a sharp tick again. The clock reasserts itself, and yet the memory of quiet time, the suspended seconds, the slow rhythms, stays. You don't have to leave Earth to taste this quiet. Tonight, as you lie still, gravity pressing softly into your mattress, sound fading to a hush, light dimming gently into shadow, you can feel it. The quiet of orbit exists in your own silence, in your breath, in the soft beating of your heart, in the seconds you no longer chase, but allow to arrive. Time does not only belong to clocks, it belongs to the spaces between tasks, the pauses in thought, the weightless moments of stillness. And in orbit, where every second is stretched by gravity and motion, you begin to see what those moments truly are, pieces of eternity, floating gently by.
There is a photograph, quiet, simple, and yet extraordinary. It shows two men, middle-aged, identical in face and frame, standing side by side in matching blue flight suits. One has just returned from a year in space. The other never left Earth. They are twins, but their journeys have bent their time. What began as a perfect mirror has become an experiment, not just in science, but in time itself. And what it reveals is both stunning and deeply human, that even in a shared body, time can unfold in different ways. The story of Scott and Mark Kelly is more than a tale of endurance. It is the first full attempt to understand what happens to the human body and to human time when it is stretched between Earth and orbit. When Scott boarded the International Space Station for his nearly 12-month mission, and Mark remained on Earth, NASA saw an opportunity, not just to measure muscle loss or immune function, but to glimpse what it means to live differently in time and to return changed. From the moment Scott left Earth, the clocks began to diverge. His seconds, influenced by speed and distance, began to pass ever so slightly slower than his brothers. Not metaphorically, not spiritually, physically. His orbit high above Earth's gravity and traveling at thousands of kilometers per hour placed him in a frame where time stretched. Every day, every breath, every thought aboard that spacecraft happened within a different tempo than the life unfolding below. Of course, neither brother felt it. For Scott, the days passed in loops, light and dark cycling, every 90 minutes, tasks rotating with precision. For Mark, the world moved on, the weather changed, politics shifted, lives grew and aged, and yet, for all the noise of Earth and the stillness of space, their personal experiences of time felt normal. Each man lived his days without sensing the drift, but the drift was real. The difference? Around 5 milliseconds, 5,000ths of a second by the end of the mission, a sliver of time, the blink of an eye, but hidden within that blink is the entire truth of relativity. The clocks, once identical, once perfectly synchronized, no longer matched, and though the body may not feel a millisecond, the universe does. It marks it, it holds it, it remembers it. But there's another layer to this story, one that goes beyond the tick of time and into the lived reality of two brothers, separated not by choice, but by gravity. Imagine knowing that your sibling is floating above you, circling the earth again and again while you sit at home. Imagine birthdays passing alone, conversations delayed, glances only possible through a screen. It's not just the distance that separates you, it's the rhythm. Your days are not his days, your sky is not his window, your minutes, though similar, are not aligned. And for Scott, imagine looking down on the world you know, again and again, without ever stepping into it. Imagine seeing your home, your country, your brother, over and over, always near, never close. Time in space is not just slower, it is quieter, more internal. The sameness of the station, the repetition of routines, the strange silence of zero gravity, they all create a new kind of time, one where memory begins to blur, where dreams stretch longer, where emotions rise and fall in unfamiliar patterns. During the mission, scientists measured more than clocks. They studied telomeres, the protective caps on the ends of chromosomes, and found that Scott's had lengthened in space, the opposite of what they expected. His gene expression changed, his microbiome shifted, his eyesight altered. In some ways space seemed to reverse aging, in others it accelerated it. Upon returning, many of those changes reverted, but not all. Some stayed. This shows us that time is not just a ticking number, it is physical, it is embodied, it etches itself into our DNA, our bones, our breath. When time bends, we bend with it. When we leave Earth, we leave not just our home, but the clock that shaped us. And yet, in all this science, there is a thread of something deeper, the human longing to reconnect. When Scott returned to Earth, he and Mark were once again side by side, but they were no longer perfectly the same, not because of age or experience, but because time had split. They shared a beginning, yes, but now carried different durations inside them. And this is the lesson time teaches us, that even with the same face, the same blood, the same origin, our journeys create divergence. that time is not only what we measure, but what we become. Each path through the universe writes its own tempo, and even the tiniest shift, a few milliseconds, a few heartbeats, holds the power to shape a life. So tonight, as you lie still, think of the sky above you. Somewhere, a satellite arcs through shadow. Somewhere, two brothers, once the same, now carry slightly different clocks in their bones. And you, with your own breath, your own rhythm, your own stretch of seconds, are part of that same story. Time does not divide us. It reveals us, gently, silently, differently. The earthbound wait is longer than it seems. When someone you love leaves for space, the clocks on Earth don't just keep ticking, they deepen. Every second becomes heavier, stretched not by the physics of velocity or gravity, but by the strange elastic nature of anticipation. When Mark Kelly remained on Earth while his twin brother Scott circled the planet again and again, he wasn't just watching from a distance, he was living through a parallel kind of time, one shaped not by relativity, but by memory, reflection, and the quiet erosion of routine. Mark's world stayed mostly the same. The sun still rose, and set on a familiar schedule. Meals followed the comfort of gravity. Days came with seasons, weather, human contact. But even within that predictability, something subtle shifted. The absence of his twin, a brother whose biology, voice, and past had always mirrored his own, created a temporal rift. It wasn't that time moved slower or faster, it was that it moved differently. Every event was marked by his brother's absence. Every decision became a quiet reminder that someone was missing from the world below. And this is the hidden story of spaceflight. For every person who launches into the sky, there is someone else who stays, someone who keeps the fire burning, who answers the questions, who waits for the return. These earthbound companions are part of the mission too. Their time, while unaffected by relativistic drift, becomes just as distorted, stretched by longing, marked by repetition, colored by the silence of the unanswered call. Imagine what it means to track someone through orbit, not just with data, but with emotion. Mark could follow Scott's path through NASA updates, through telemetry, through carefully scheduled conversations. He could imagine where the station was, over the Pacific, over the Sahara, gliding silently above the sleeping continents. But that information did not close the gap, it only made it more precise. He knew exactly where Scott was, and still the distance felt infinite. And in that precision lies the paradox of modern timekeeping. The more accurately we measure time, the more acutely we feel its absence. Mark had access to every detail, the velocity of the ISS, the oxygen levels, the crew schedule, but none of that made Scott's presence any closer. In fact, it heightened the awareness that his brother's seconds were not the same as his own. This is what time does to those who wait. It stretches not just through physics, but through emotion. A year on Earth is a long time when it is watched from the ground. Holidays pass, conversations start and stall, life continues, but it always pauses for the thought, he's still up there. Mark lived in a kind of suspended reality, his routines unchanged, but his perspective constantly turning skyward. Waiting becomes a rhythm of its own. There is the ritual of checking in, the anticipation of communication, the moments of silence when the link drops, or the signal lags, even the knowledge that your message might not be read until later, that your words must travel not just through space, but through the timing of orbit, creates a lag that seeps into your bones. But waiting also sharpens presence. Mark may not have felt time slow down in a physical sense, but his awareness of each moment became heightened. Every news headline, every passing season, every turn of the earth held a deeper awareness. He began to track time, not just by the calendar, but by how long Scott had been gone. Time became personal. It became tethered not to clocks, but to connection, and all the while, the earth itself became a reminder of difference. The sky that Mark looked at was the same sky Scott passed over, but it meant something different to each of them. For Mark, it was a ceiling. For Scott, it was a window. That contrast is subtle but profound. One saw stars, the other saw the ground. One felt the pull of gravity in every step, the other floated in its absence. Their experiences diverged, even as their DNA remained the same, and yet they remained bound, not just by biology, but by the stretch between them. Scott's time was moving slower in orbit, yes, but Mark's time was changing too. He was not affected by velocity or altitude, but by something just as real: distance. It created a different kind of dilation, one not of seconds or milliseconds, but of emotion, of memory, of the ache of separation. Still, there was comfort in knowing the return was planned, that the wait had an end point, and in this the nature of time itself reveals its duality. It is not only measured by seconds past, but by how many are left. For Mark, each day was one closer to reunion, one more breath along the arc of coming home. And when Scott did return, when his boots touched down, and his body once again felt the full weight of Earth, Mark wasn't just welcoming his brother back, he was reuniting with someone who had lived through a different clock, a different cadence. They had parted in sync, and returned slightly out of phase, and yet their lives folded back together, like two pages from different books, suddenly stitched into the same story. This is what time teaches those who wait, that even when separated by physics, by distance, by the subtle drift of seconds, connection can endure, that love, memory, and presence are not tied to the same constraints as light speed or gravitational wells, and that sometimes the most profound changes happen, not in the place of motion, but in the stillness of those who remain. Tonight, as you breathe softly, held by Earth's quiet gravity, think of the people who wait, for travelers, for answers, for return. Think of those who hold time not with clocks, but with open hearts, and remember that the ones who stay behind are always part of the journey too. When two clocks reunite after walking different paths, the story they tell is no longer the same. Their hands may once have moved in perfect rhythm, ticking in unison with each breath, each thought, each heartbeat shared between two people, but once time has stretched between them, once gravity, velocity, or distance has nudged their seconds apart, the return is not simply a continuation, it is a quiet reckoning, the reunion of two timelines that once matched, now forever altered by the journey each has made. When Scott Kelly returned to Earth after his nearly year-long stay aboard the International Space Station, he was welcomed not just by family and friends, but by the weight of gravity and the unfolding truth of time. His brother Mark greeted him with the same smile, the same voice, the same history, but within them lay two different durations of experience. The bodies looked the same, the hours felt the same, but the clocks, those invisible instruments ticking in the blood and bones of each man, no longer aligned. It is easy to imagine time as something immaterial, a backdrop to action, a setting for story, but in this reunion, time reveals itself as something deeply physical. It resides in the spine, the joints, the skin. When Scott stepped back onto the Earth, gravity reasserted its hold, the blood rushed downward, the pressure in his head changed. His muscles, unused to supporting his frame, sagged under their forgotten burden. He was heavier, not just in mass, but in the sensation of time pressing down. Mark, in contrast, had never left. His body had aged by a fraction more, not enough to notice, not enough to speak of, but enough to matter in the realm of physics. And yet the difference was not in numbers, it was in experience. Mark had watched the world change, while Scott watched the world turn. Mark had waited through seasons, Scott had counted orbits. They had both lived the same length of time, but in different rhythms. This is the heart of relativity, not just the mathematical difference, but the human one. We think of time dilation as a fraction of a second, a curiosity of motion, but when you live it, even in the smallest of ways, it becomes something else entirely. It becomes a realization that your life is not only what you remember, but when you remember it, that memory itself is tied to tempo, and when your tempo changes, so too does your place in the story.
For Scott, re-entry was both a return and an awakening. His body had learned to live in weightlessness, and now it had to relearn gravity. The stiffness, the nausea, the fatigue, these were not signs of weakness, but of realignment. His internal clock, stretched ever so slightly by orbit, was trying to sync again with Earth, but it couldn't erase the time he had lived outside of it. And for Mark, the reunion brought a different kind of awareness. He had stayed grounded while his brother had drifted. He had walked through days that his twin would never truly feel in the same way. Even their memories of the same year now belonged to different calendars. One had seen it in headlines and weather, the other in cycles of sun and silence. Their reunion was warm, full of jokes and hugs, and shared relief, but it was also layered, two lives reconverging after taking separate paths through the same river, like two leaves that drift apart in a stream, and rejoin downstream. They were together again, but not unchanged. Something had shifted, and both could feel it. The scientists, of course, measured everything. They recorded DNA, immune responses, cognition, gene expression, heart rate, sleep, but what they could not measure was the quiet moment when the brothers stood together again, not as test subjects, but as twins who had briefly lived in separate timelines. That moment, unrecorded, undigitized, was where the deepest truth lay, that even the smallest difference in time can make you pause and look at each other with new eyes, because time doesn't just pass, it carves, it shapes, it leaves its imprint not in minutes, but in meaning. And when you return from a different path, be it orbit, illness, grief or distance, you do not return to the same moment. You bring with you a new tempo, you carry your own rhythm, and in doing so, you must learn how to listen again to the rhythms of those you love. This is what makes reunion both beautiful and delicate. It is not just a celebration of being together again, it is a negotiation, a slow tuning of hearts and clocks, trying once more to match their beats. For Scott and Mark, it was laughter and meals and storytelling. For others it might be silence, a soft hand, or the patient waiting for a shared dream to return. And perhaps this is why time dilation matters, not because it changes how we count seconds, but because it changes how we understand connection. It reminds us that we can be made of the same stuff, begin in the same place, and still grow apart, not in love but in tempo, and that to reunite is not to erase the difference, but to honor it. Tonight, as you close your eyes, and let the day slip away, think of your own rhythms, the way you carry your time, shaped by your motion, your memories, your silences. Think of those whose time has drifted from yours, by distance, by experience, by life, and know that every reunion is a chance to listen again, to adjust, to come back into rhythm. You don't need to travel to space to understand this. It happens every day, in every home, in every quiet moment when two people look at each other and feel the echo of separate seconds returning to one.